It's Thursday, 21st of September 2023, and welcome to the Water Action Platform, where we proudly share stories from across the global water sector. I'm Karyn Georges, and this month we'll be covering 3 exciting topics, all linked by a common thread of how we can address complex environmental problems in a collaborative and holistic way. Stay tuned to the end to hear Ars's CEO Ben Tam talk about COP28. I want to start by saying a huge thank you to all of these organisations for continuing to sponsor our Water Action Platform. In today's episode, we'll hear about some new research on microplastics, and we are bringing back our popular Both Sides Count feature, where 2 water sector experts participate in a short, punchy debate on whether we can achieve net zero carbon without compromising other environmental goals. We will also hear from an award-winning scientist on how she overcomes challenges in her work. As always, if you click on the arrow on the right-hand side of the screen, you can access the chat. There is a link in this chat room which will give you access to subtitles that provide a more inclusive viewing experience. Our first segment is on microplastics. Microplastics are very small pieces of plastic which range between 1 micron and 5 millimeters in size. Primary microplastics are designed for commercial use, such as those found in cosmetics or microfibers shed from clothes. Secondary plastics are particles that result from the breakdown of larger plastic items like water bottles. We have heard in previous water action platforms, and no doubt you've read in the news, that microplastics have been found across the globe, in all waters, in air, in humans and in animals. Research undertaken over the recent years has highlighted how they can act as carriers or conduits for chemicals potentially impacting on human and ecosystem health. These microplastics can end up in our drinking water, in our wastewater, and subsequently the sludge that is produced during treatment. Companies across the globe are working hard to develop solutions, and governments are formulating regulations and management strategies to reduce the impact of society's use of plastic. This brings me to introduce our first guest, Dr. Alice Horton from the National Oceanography Centre in Southampton in the UK. Alice is an anthropogenic contaminant scientist with expertise in the fate and ecological effects of microplastics in aquatic environments. Her research focuses on how the connections between land, rivers, lakes and oceans lead to the transport and accumulation of microplastics within the environment, their associations with organic chemicals, and how these processes influence the interactions and effects of microplastics on aquatic organisms. Alice has an extensive publication list, including studies regarding the identification of microplastics in UK rivers and freshwater fish and their effects. I had a chat with Alice last week to find out more about her current research.
Now, one of the key projects that I'm currently working on is called LabPlas, and this is an acronym for Land-Based Solutions for Plastics in the Sea. And this is looking especially at the sources, distribution and pathways of microplastics from land through major European rivers into the North Sea, as well as trying to assess the seasonal distribution of these plastics and whether it varies depending on when in the year you look for them. We're also trying to understand the ecological interactions, so how biota are interacting with microplastics and ingesting them, and also the ecotoxicological effects of these particles on those organisms. And the emphasis of this project is especially to look at particles smaller than 100 microns in size, so really at the smaller scale of the end of microplastics, because we know that these small particles tend to be the most hazardous when it comes to the ecotoxicological effects on organisms and ecosystems.
I asked Alice where the uncertainties lie in research around microplastics.
With respect to the unknowns about microplastics, the long-term ecological effects are something that we really don't understand very well at the moment. We know that ecosystems will be exposed to microplastics for long periods of time because plastics in the environment don't tend to degrade very quickly. They have a very long residence time and they move around and they change their characteristics. But ecosystems and organisms will be exposed to them. We know that there can be toxicological effects of this exposure, but not what this means for future projections of the health of these ecosystems. We also have questions about human health effects. We don't really know what the effects of small plastic particles, microplastics and nanoplastics even, are to humans. We know that we ingest them, that we breathe them in, they've been found within human tissues, but not what the effects of these are. And that's not to say that we should all go out and panic about the fact that plastics are going to cause huge harm to humans, but we do need to try and understand what those effects might be. We also want to try and understand the timescales of persistence and residence. I mentioned that plastics are present for long periods of time within the environment, and we hear these statistics about one plastic bottle, for example, will last 450 years. Now, this is a huge estimate, and this really depends enormously on where this item ends up within the environment. If it's in the deep sea, it will degrade far slower in these very cold, dark conditions than it will on a beach where it's exposed to sunlight and breaking waves. The final thing I wanted to highlight is research into novel materials. So if we're trying to change or reduce the way in which plastics are used, we might need to replace some of these with different materials. And we need to understand that these might be beneficial, but they might also have their own issues when it comes to their breaking down and their residence within the environment. So this is something we really need to research before we start using these materials more widely.
So microplastics don't respect country borders and move across different environmental mediums, requiring a range of disciplines and stakeholders to work together to address the problem. I asked Alice what role collaboration was playing in microplastics research and management.
There are also lots of instances of nations learning from other nations. For example, when it comes to the microbead ban, the first country to enact this was the Netherlands in 2014. And since then, we've had bans across the globe, from the USA all the way through to the UK in 2018. In terms of research collaboration, this is the way in which we do all of our research. So we very infrequently do research within one organisation. We tend to work cross boundaries, cross institutes, and across the globe to develop solutions, to develop innovative ideas, to carry out the best research that can produce evidence that can help other people, for example, governments develop policies, can contribute to industrial decision-making on the way in which plastics are manufactured, and so on. So research cannot be done alone and is a huge collaborative effort.
Some great insight from Alice on microplastics, providing a great example of how the actions of society, in this case the use of plastics, can have wide-reaching environmental impacts which we are only now beginning to understand. We have a live poll in our chat about microplastics management. Click on the right of your screen to open it up and then vote. Keep an eye on our social media to see the final results. Now, as Alice pointed out, environmental issues can be complex and cut across different disciplines, requiring bright minds and an optimistic nature to solve. This brings me neatly onto our next section. In Both Sides Count, we have two senior figures from the water sector present the case for or against a particular issue. This week, the issue is around the presence of trade-offs in environmental management and decision-making. Can we really achieve net zero carbon without compromising other environmental goals? Or are we just encouraging siloed thinking and focusing only on one issue to the detriment of others, like water quality and pollution? Our two guests for Both Sides Count today are Steve Bungay, Technical Director at Mott MacDonald, arguing the case against, and Austin Alexander, Vice President, Sustainability and Social Impact at Xylem, arguing the case for. As you listen to the debate, you too can join in. Click on the purple arrow to the right of your screen to open up the chat and add your own thoughts. Let's hand over to Steve and Austin.
Net zero greenhouse gas emissions can be achieved without sacrificing other environmental goals. In the case of net zero emissions, the benefits of achieving net zero can also come with other benefits that help drive other goals. Net zero drives smarter management of assets in any organization, and who wouldn't want that? As an example, reducing emissions related to electricity use often also drives operational savings. Improving visibility and management of emissions also improves waste and water metrics in other areas of the business. Smarter data and management of supply chains can also provide improved management in other areas of procurement and other procurement goals. And circularity design in products and services can minimize emissions, but also often minimize the water, waste, and materials required to produce those products and services.
Can net zero carbon be achieved without sacrificing other environmental goals? The water sector has ambitious plans to achieve net zero. However, are these plans realistic? Is net zero by 2030 achievable, let alone 2050? Does the route map, the methods of carbon accounting and reporting, mean we lose sight of climate change and what is required to minimise the warming trajectory we are currently on? Carbon offsetting and sequestration is incredibly complicated. Are trade-offs acceptable? Is it appropriate to plant trees to continue polluting the atmosphere? And are nature-based solutions carbon sinks or carbon sources? And does carbon offsetting and storage generate the carbon benefit claimed? And how do you work out that trade-offs are acceptable? The simple answer is you don't. They are not acceptable. Carbon offsetting uses disingenuous accounting to allow organisations to ignore climate change and carry on regardless.
In our modern world, many environmental challenges are being exacerbated by climate change caused by increased emissions in our post-industrial world. So by not doing everything in our power to address emissions and reach net zero, we're making the root cause on other environmental issues worse. The impacts of climate change are already impacting us, becoming visible in ways impacting other areas of the environment, like water availability and quality, biodiversity loss, flooding, and more. Not addressing these emissions will make other environmental challenges that organizations face worse. So you must address net zero in order to address other environmental challenges.
Sometimes we need to step back and consider the bigger picture. We mustn't forget the environmental and public health benefits arising from improved sanitation. Sanitation has contributed more to public health than modern-day medicine, and it continues to provide environmental benefits. Yes, the water industry needs to reduce process emissions from wastewater treatment. However, putting the benefits of sanitation to one side, sewer methane will dwarf the emissions made from wastewater and sludge treatment. Yes, the water industry needs to improve its energy efficiency. And yes, it needs to expand its use of self-generating renewables, such as solar power and anaerobic digestion. Net zero ignores nitrogen oxides, such as nitric acid and nitrogen dioxide. It ignores PM2.5, and it ignores ammonia, all of which are atmospheric pollutants that are generated by the water industry. And why is biogenic carbon ignored?
Finally, it's called being able to walk and chew gum at the same time. Any business or organization in the world has to be able to balance multiple goals at the same time. It's just part of operating in a modern world. And the same goes for environmental and sustainability goals. We have to be able to reach net zero while also managing other environmental goals. Doing so just means running a business well in today's environment.
Focusing on net zero, trade-offs hinder long-term solutions to climate change. They're a get-out-of-jail card for organisations and governments alike. It's not just that net zero can't be achieved without sacrificing other environmental goals. Are the other environmental goals more important than net zero? And without a major paradigm shift, net zero is simply not achievable.
So, both sides are compelling. What did you think? And more importantly, what did they think? Were they genuinely arguing the case that they believe, or were they putting forward a case for the opposition? Let's hear what they say.
So what do I actually believe? I agree with everything I've already said. Trade-offs should not form part of our climate change strategy. Ignoring biogenic carbon is tantamount to negligence, and arguably, using trade-offs is ecocide by the back door. However, we need to stop and think. Given the ecological improvements we have made over the last 100 to 150 years, is a single vision on net zero appropriate for the greater good?
And finally, the truth, I do believe net zero greenhouse gas emissions can be achieved without sacrificing other goals, but I will admit it is difficult and it has to be done carefully. We do risk sacrificing other environmental goals if we are only tunnel visioned on greenhouse gas emissions alone. But balancing and keeping multiple goals in place is called leadership, and it is doable.
So there we have it. From the value of leadership and empowering your team to work together to solve environmental challenges, to the technical nuances of what really are the trade-offs, how do you measure them, and what is acceptable? However, both are agreed that the goal of net zero carbon cannot be taken in isolation from other environmental goals. Thank you, Steve, and thank you, Austin. If you want to be involved in a future Both Sides Count segment, just let us know. So you'll have picked up this thread from this webinar from our previous speakers. There is complexity in understanding environmental issues and in communicating them. The life of someone working in the sector is not easy. We all face challenges in the work we do. This feature is around the rest of the iceberg. How do successful water professionals navigate some of the challenges they face in their working lives? My guest is Usisipho Feleni, Associate Professor and Thematic Area Leader for Applied Electrochemistry at University of South Africa's Institute for Nanotechnology and Water Sustainability. Usisipho was recently awarded the prestigious Emerging Researcher Award at the National Science and Technology Forum South 32 Awards. This recognises her for her contributions in electrochemistry with emphasis on electroanalytical sensors and biosensors comprising nanomaterials. These contain unique and specific features for the use in electrochemical sensing and signalling of diseases such as HIV, TB and cancer, as well as monitoring water contamination. I caught up with her to find out more about what motivates her in this important line of work and how she addresses the challenges she faces. I started by asking her what inspired her to pursue this path.
I wanted to be a pharmacist when I was growing up, but then I think as I was getting good marks in high school, I decided to take a path in chemistry. And the fact that I lost an aunt due to HIV, but she was taking medication. So I wanted to understand why are people dying while taking a medication. So I started branching into research whereby I was preparing nanomaterials and using enzymes that were mimicking human body so that we can understand the drug metabolism rate. So I studied that from my honors level. I was checking the toxicity level as well as just trying to figure out the type of metabolism rate for different patients. So I continued with the research in TB research because, of course, there are so many people dying because of TB.
What an inspirational way to get into research. How did you go from your medical research in TB to water research?
So after my PhD, I moved into the University of South Africa, where I started research in water purification, whereby we are preparing various nanomaterials with specific features. And we use those nanomaterials for biosensor applications and trying to figure out the type of concentrations that we find in water, particularly pharmaceutical contaminants, starting from HIV drugs, TB drugs, as well as other drugs that are found in water samples.
So we talked about some of the challenges with ensuring solutions you're developing are suitable for the community they are meant for. And I asked Usisipho about how she addresses this.
I do have an engaged scholarship in my hometown whereby we are showcasing nanotechnology applications, because where I come from a rural area. So many people, the grandfathers, grandmothers, they have challenges with water. Secondly, we have challenges with diseases such as diabetes. So my research in my hometown has to do with trying to teach learners, teach the community about the challenges we are facing and how can we develop technologies that can assist my community, especially rural villages.
Thank you so much. Can you talk about how you were able to share this information with the communities involved?
Luckily for me, I'm a Xhosa woman. So my community in the Eastern Cape, we speak Xhosa. So of course, we have to be balancing isiXhosa and English. But when we are communicating, of course, we are not using deep science. We try to make them visualize these nanomaterials because we cannot be talking about nanoscience. Many people do not understand what nanoscience is all about. If we are talking about nano, 10 to the power minus 9, meaning that we have to look under the microscope. So we try to use a similar format so that grandparents or the people in the villages understand. And luckily for me, my mother is a teacher. So I ran those ideas with her to say, oh, does this make sense if I'm putting it like this? So we speak in Xhosa as well as in English so that everybody would understand. And just to say that we also run Science Week. So my focus on the Science Week is based also in the Eastern Cape because we are not that privileged in the rural area. So one way of me giving back to my community is to make sure that I focus my own research because I grew up without having people guiding me on which path to take. So it is my responsibility as someone who has gone over this path to tell them that, yes, we understand that we don't have many equipment. We do not understand so many things from the rural area. But we can try as much as we can to go there every quarter to teach them. And also, luckily now we have social media. We can run some classes over online so that they understand. And they do ask questions now because they understand what nano is all about and the type of technologies that we use for improving the quality in South Africa as well as worldwide.
So it's such a reflective and responsive way of approaching research and ensuring its community impact. I ask her what advice would she have for anyone wanting to follow in her footsteps?
So first of all, I always talk about the National Development Plan. There's a National Development Plan 2030, Africa Agenda 2063, and National Innovation System. So I always refer to that because those are the policies of the strategies that we are using and benchmarking according to that. So if people want to come to this path, of course, they have to understand what are the challenges we are facing in South Africa. If we're focusing on South Africa, we have issues of load shedding. That's not the first thing. We have issues of diseases. We have issues of so many things. So, of course, we want to solve problems that are challenging us, Africa as well as elsewhere. So I would say the advice I would give is that we need to train the next generation and to transfer all the skills that we have so that we can not only develop the technologies that we talk about, we can even create companies that will open jobs because we do not have jobs. Many people have graduated, but we do not have jobs. So if we can take what we know, transfer it to the next generation, and ensure that they open companies that would assist with job creation as well as, transferring the skills and competing with other countries based on the technologies that we are capable of doing.
Thank you, Usisipho. Some wonderful insight about the need to engage with the communities on the right level and with the right language. Her enthusiasm for empowering the next generation to enter into research and innovation and develop commercial products demonstrates that great leadership. So later this year, ALSA's CEO Ben Tam is heading to COP28, the 2023 UN Climate Change Conference, and here he shares some of his hopes for the event.
I'm excited to say that I'm going to be heading out for COP28 in December. Hosted in UAE, it's certainly a region which understands the challenges around water and climate. I really want to connect with our global network to see who else will be traveling out there. And part of this is that call out to get that story started and get those connections going early. In my mind, it's really clear. Water is intertwined in terms of greenhouse gas emissions. Somewhere up to 6% is out there in the research. And of course, water also touches some other key areas which will come up through the agenda and the thematic themes this year, especially around agriculture. So I'm really keen to see what the role for water management, provision, treatment around agriculture and also other industries. And also, then finally, what kind of climate finance is going to be available to support new solutions, the adoption of new solutions to get us through to where we really need to be. So at ISLE, we're constantly tracking and seeing those exciting technologies coming through. We want those to be championed as heavily as possible through this process. The world's leaders, the world will be watching to an extent. And it's our chance to make sure that the best solutions are landed in the right places. I'm also keen to connect with the decision makers who will also be going out there to see how we also might make the case for the best investment into the water sector as possible. I look forward to connecting with you all. See you soon.
And finally, so humans have pumped enough water from underground reservoirs to shift the Earth's geographic or rotational North Pole at a speed of 4.36 centimetres per year. Now, researchers published their discovery in an article in Geophysics Research Letters in June this year. And they discovered that from 1993 to 2010, humans displaced more than 2 trillion tonnes of water by removing them from underground reservoirs, which has caused this shift. But why is this important? Well, the axis of the Earth is spinning around, or the axis that the Earth is spinning around is a rotational or geographic North Pole. Now, this axis is relative to everything else in our solar system, and it's not perpendicular to objects such as the sun, but instead is at an angle of around 23.5 degrees. Now, this tilt places the northern and southern hemispheres at different distances to the sun and produces summer and winter time. This angle can vary naturally from as much as 22.1 and 24.5 degrees, but over about 40,000 years. The largest changes in the Earth's axis occur seasonally due to the shifting motion of atmospheric masses as weather and seasons change, causing the geographic poles to wobble by several meters annually. Now, this movement of water, such as melting glaciers and ice caps, plays a role in water-induced axis shifts. However, in the last 2 decades, this change has been much more rapid. Since 2003, the axis has moved 78 centimetres. Maybe that doesn't sound like much, but this is entirely caused by humans. So how did we find this out? Well, when Seo and his collaborators tried to model the Earth's water content to account for how much the axis has tilted, they could not fully explain the data. Adding the effects of changes in surface reservoirs didn't help, so they looked at groundwater. Gravitational surveys have measured the depletion of underground reservoirs, which is caused in large part by irrigation, especially in northwestern India and western North America. These surveys show that groundwater pumping shifted enough mass into the oceans to cause 6 millimetres of global sea level rise between 1993 and 2010. By including these changes in their model, the authors calculated that they should have a substantial impact on the Earth's rotational axis, and they predicted that the displacement of groundwater alone causes a shift in the North Pole of 4.36 centimetres per year. Now, whilst the rotational North Pole normally does change by several metres within about a year, these changes due to groundwater, do they have that risk of shifting seasons? No, not really. But on geological timescales, polar drift can have an impact on climate. And this, combined with the rise in sea levels, demonstrates just how much of an impact and unintended consequences human activity can have. Now, heavy in the news this week was a devastating earthquake in Morocco and the catastrophic floods in Libya. With the terrible loss of life and the devastation of communities, our thoughts are with all of those who are affected. There are a number of charities who are running campaigns for disaster relief, and an internet search will bring these up. On the screen are just some of those who are helping in this region. And with that, we come to the end of this month's broadcast. I once again thank all of our contributors and sponsors. Next month will be hosted by Piers Clark on Thursday, the 19th of October, and I'll hope you join us. Until then, keep asking questions, keep sharing, and keep safe.